Hello, good evening, Dr. Prabhu Chandra, sir. Am I audible, sir?
Yes, am I audible?
Yes, sir. You're audible,
Yes,
sir.
yes, thank you.
Okay, sir. Can I start? Welcome back, everyone. We now proceed to session 2 of day 5. It's a great pleasure to introduce our next speaker, Dr. Prabhu Chandra from Chandra Research Lab Private Limited, Maila Duthurai, Tamil Nadu. Dr. Prabhu is an internationally recognized researcher in wireless communication, 5G, 6G technologies, massive MIMO, drone communication systems, and AI-driven radio signal processing. He is currently the director of Basic Wireless Laboratories Private Limited, Maila Duthurai, and also serves as the director of Chandra Research Labs Private Limited, Chennai, where he leads cutting-edge research and product development in next-generation wireless systems. Dr. Prabhu completed his PhD in wireless communications from the highly reputed GS Chanel School of Telecommunications, IIT Kharagpur, and later worked as a postdoctoral researcher at the Division of Communication Systems, Linköping University, Sweden. His research contributions span a wide range of advanced wireless technologies, including massive MIMO, drone swarm and UAV communication, deep learning for wireless signal processing, OFDMA systems, cognate radio, 5G, 6G system design. Dr. Prabhu has designed several practical wireless technology platforms such as 5 Radio, that is a complete 4G, 5G testbed, Deep Radio, an AI-driven wireless research platform, YESDR, an AI-powered private cellular standard, Wi-Fi, Wi-Fi, GUI, and SDR-based wireless learning tool. Later, a 5G-enabled drone platform. He is an active member of IEEE also. Dr. Prabhu will be speaking on 5G, 6G-enabled smart farming use cases and applications, a highly relevant area where next generation communication system transform agriculture, automation, and smart sensing. Sir, we are honored to have you with us today. I request Dr. Prabhu to begin the session. The virtual stage is yours, sir.
Thank you, Rahul, for the kind introduction.
Thank you, sir.
Is my screen visible?
Yes, sir, your screen is visible. I can see your first page of your PPT, sir, with the title.
Okay, thank you.
Thank you.
Good evening to all. So in this session, I'll be discussing about how 5G and 6G enabled smart farming going to change our lifestyle in the coming years, and how we can also make test beds for 5G enabled smart farming. So we'll start with the evolution of cellular systems and different use cases applications of 5G, and how you can develop test beds to show the potential of 5G enabled smart farming. So as we know, we are currently in the era of 5G, and already 5G has been deployed throughout the world in 2020 onwards. Within next 5 years, we will be seeing 6G as well. So 6G will be advanced version of 5G with AAML capabilities. Right? So this is a summary of evolution of cellular systems from 1G to 5G, where in up to fourth generation we were using the phones and handheld devices and smartphones mainly for human communication, exchange information like voice, video, all those things. But in 5G, it will be mainly focused on integrating um, IoT um, networks involving industrial automation, smart transportation, agricultural automation, and home automation, all those things. Practically, other than the smartphones, all the devices in the world will be able to connect to the 5G ecosystem. So this is a summary of evolution of the cellular system, both in the core network and access network. In the top portion shows the core network architecture. In the bottom portion shows the access network architecture for 2G, 3G, 4G, and 5G. So in the access network means then the network involves the base station and the user equipment. That is access network. Core network means something running in the background, right? So that will be controlling several hundreds of base stations or thousands of base stations. So core network components are the main components that handles registration, security, data handling, all those things. So whenever we are discussing about 5G enabled smart factories, smart farming, or AIML based 6G networks, right? So all those things involving the mainly on the core network side. So whenever you do research, you focus on only on the physical layer and the MAC layer like that. But when from the 6G, 5G onwards, things are going to change. So we have to do a lot of stuff in the core network also. So if you see that only 2G setup in the base station, there are BTS, base station transceiver station, and base station switching controller, and the transceiver like access network. In the core network, we have a home location register and gateways, mobile switching center, all those things. But when it comes to 4G, we have evolved node B, and there are nodes called MME, HSS, right? MME, Mobility Management Unity, SGW is Serving Gateway, PW is like PDN Gateway. So the PDN Gateway, Serving Gateway, they connect our 4G system towards the internet, right? That is called Evolved Packet Port. In 5G, we have different modules like AMF, SMF, Session Management Function, Access and Mobility Function, User Plane Function, with several names. So the core network, the access network is called as GMB, next generation base station. So one major difference between 4G and 5G is that in 4G, these components, individual components are kind of um, hardware, fixed dedicated hardware equipments. Will be manufactured and sold by some specific vendors like Nokia, Siemens, Huawei, all those things, right? But when the problem is that when you are moving from 4G to 5G or 5G to 6G, we have to entirely change the hardware, right? Even they have to change the whenever some operators like Jio, Airtel, they are moving from 4G to 5G, they have to change the base station equipments, also the core network equipments. It costs lakhs of crores for them because if you see India, in India itself, more than 20 lakh base stations available. So if you are going to change the entire network for every 10 years, because the cellular systems are changing for every 10 years, right? 4G, 5G like that. So each generation goes for 10 years. So that is it costs a lot of money for the operators. To avoid that, what they are doing in 5G, in 5G, they are mostly implementing the core network components using software packages. So that when we are moving from 5G to 6G, you can just upgrade the software with minimal cost. So with keeping that in mind, nowadays all the core network components are kind of software services. So anyone could develop the service and put it in the cloud. The operators could utilize that. For example, companies, as IT companies like Wipro, HCL, or Infosys, they are also developing the core network components. Because the core network components has to support lag services, right? So the latency has to be minimal, and it should be able to handle a lot of throughput, because each user will be having hundreds of MBs data rate. So overall, if you count the lag services, the several TBs of data has to be handled by the core network. For that reason, so all the IT companies also kind of into the development of core network. So when you are implementing these things in core network using software packages, software modules, we will be able to efficiently integrate the AI and ML techniques in the core network side. So our 6G networks are moving towards that direction. So in the summary, from 5G onwards, the 5G core network core network components will be software packages that will be upgraded. Instead of replacing the hardware components, you just upgrade the software. So the core network can be kept in the cloud. Need not be a physical device kept in locally for the operators. It can be kept in the cloud, so that can be utilized. So as I said, not only for human communication, now 5G involves machine-to-machine communication, IoT, smart farming, and smart transportation, all those things, right? So there are certain things like edge computing, all those. In 4G, we had, per base station, the connectivity requirement is 1,000 users kind of thing. For example, in 1 square kilometer, there should be 1,000 users will be having smartphone. They will be connected to this one square kilometer. But in 5G, it can support 1 million devices per square kilometer with several QoS requirements. Because the IoT if you assume any home, the home itself having a lot of appliances, um, machineries, lights, traffic lights, all those things, right? So even if you kind of think of a city, um, several cameras, CCTV cameras have been kept for monitoring traffic handling, all those things. So if you count all those devices, it would be several lakhs, even per kilometer square. All the including all the vehicles, all those things. So the 5G is capable of supporting a large number of devices. So now it is more suitable for industry 5.0. So already we know that um, industry revolution started from 1970s. Sorry, yeah, in 17th century, right? So from now we are in the era of industry 4.0, where all are going to be connected via wireless communication. Similarly, 5G is industry 5.0 is involving the um, intelligence. This industry 5.0 involves all the domains, all manufacturing industry, including agricultural, all those things. So, in particularly in agriculture, smart irrigation, crop monitoring, autonomous machineries, they are part of agriculture. The industry automation, smart factories and robotic movement, all those things can be handled by industry automation sector. In the transportation, if you consider any city, big city, all the cars can be connected via 5G. Then the smart traffic management can be kept, including the object detection for number plate detection, overspeeding, all those things can be handled by 5G. Because the 5G is having a broader coverage. Entire region is covered by 5G, 6G network. So connectivity is not an issue. And even in healthcare industry, a lot of applications are happening. And so this is how 5G is going to play a role. So as of now, currently, if you see in India, we are not having any specific 5G use cases it is currently not running much. we can expect that things will change in coming years. Within the next 2 3 years, we'll be having a lot of specific applications. One example is that in 4G we had this if you are city, you might have experienced you are using that um, food delivery application and for transportation you are using Ola cabs and all, right? These are possible because of 4G services, right? So without 4G, we cannot enjoy these services. These are some other than smartphone communication. These are the additional services part of 4G. So similarly, we can expect a lot of things going to happen in 5G using in connected cars, home automation, industry automation, all those things. So I will give you some specific examples and some of the things already been implemented in some industrial side. I will explain that. So whenever someone is making the standard, so there are some parties involved. So you need to talk about 3G, 4G, 5G, or 6G, or 7G. So there are two parties involved. One is ITU and 3GPP. So ITU is the Interest Telecommunication Union that basically put up the requirements for 5G or 6G networks. So 3GPP is the private party. It involves academia and the industrial partners. They develop the technology. They develop and maintain the technology. Each generation of cellular systems. For example, 2G GSM and 3G UMTS, 4G LTE, and 5G NR, they are developed and maintained by 3GPP. So kind of each continent have one particular organization that will be responsible for developing and maintaining the standards. So in India, we have TSTSI. Um, so that is Telecommunication Society for Channel Development Society for India. So if someone is developing any idea or algorithm towards the 5G, 6G, they have to approach through TSTSI. So TSTSI will be coordinating with the 3GP to propose the any ideal algorithm. So currently, most of the contributions are coming from European Union because their industry and academic collaboration is very tight. They take up a lot of projects so basically the entire 4G and 5G setups are developed by European countries. So now India also taking a lot of steps towards um, contributing towards 6G and beyond wireless systems. So if this is a IMT timeline that shows 3G, 4G, 5G timelines. So in the development of any generation network, there are three stages. One is vision statement that will be made by ITU. So ITU put up that then whenever you are deploying 5G or 4G, then after 10 years, so this should look like this. That means these are the number of pieces will be there. This is the throughput requirement per user. This is the latency. Although this is the bandwidth for the base station, all those things will be defined. So based on that, the 3GP members will develop the technology. Then the deployment will happen. So if you say, if you, for example, if you take a 4G from 2000 to 2003, ITU made the documentation that in 2010 or 12 onwards, we should have the 4G services with these requirements, with this much data rate, all those things. Then in 2003 onwards, the 3GP developed a 4G setup standard for 9 years. Then from 2012 onwards, we are having the um, um, 4G deployment. We started using the cell phones and all 2012 onwards, right? That's happening. But even we think of 5G. 5G is basically extended version of 4G only. So from 2012 to 2015, they put up the requirements, ITU. Then 2015 to 20, they developed the 5G technology. Within 5 years, they're able to do it because, as I said, now it is mainly on the software-based core network, and it's an extension of 4G because in 4G physical layer we are having a OFDM kind of thing. OFDM waveforms. And in 5G, we are having more flexibility on the waveform usage. So it's a flexible, you can say 5G is a more flexible version of 4G with added bandwidth. In 4G had 20 megahertz bandwidth, 5G are having 100 megahertz bandwidth. And the channel coding and all improved a lot. But fundamentally, the 4G setup is same. In the waveform point of view, it's OFDMA. So in 5G also, it is the same thing. So same the same line. Now 6G is going to come in the 2030. Um, in the process, so now in the process of developing 5G, 5G plus, all those things, right? So one more thing, whenever um, we see it as a 3G, 4G, 5G for every 5 years, 10 years moving up, right? But in standard point of view, it is releases. Release 13, 14, 15, 16 like that. So, for example, release 10 will be 4G and release 14 will be 5G. So whenever it becomes release 2021, they become 6G. So it's kind of they put up the releases every 1 or 2 years to make the system advanced. So this is sample requirements by ITU put up in 2015 for 5G. So this is downlink data rate per base station should be 20 Gbps. There would be 1 million base stations per kilometer square. And you should have a reliability of 100 percentage, close to 100 percentage. Bandwidth is 100 megahertz. Latency is so on. So one difference with respect to the reliability is 99.9 percentage into 5G. In 4G, we used to have a single degradation indoor. If you're inside the house and all, we'll be getting poor signal, right? That is a very obvious thing. So with the 5G, they are trying to improve it a lot. So instead of relying on the cell phone towers, in 5G, there are options to deploy the cell towers in the streets also. In the streets also, in the lamp post also, you can put up the small base station. As of now, we are not seeing any such setups. In Europe and all it is there, but in whenever the signal quality is reduced or we are not getting sufficient signal quality, we can put up some cell towers in the streets also with the reduced transit power, so that all are getting equal service. So as I said, from India, there are several organizations. India Telecommunication Standards and Development Society India. That is the organization that works for standards. And there are all partners in the DVB, operators, cell phone manufacturers, algorithm manufacturers, and academy, all are part of the DVB. So as I said, the release started in 1992 for the 2G GSM. Then in 2010 we had LTE advanced 4G, and in 2000 around 20 we released 16, that is 5G. So in each releases, whenever we are doing research and development, we are coming with new ideas. Once it is if it is theoretically proposed and experimentally verified, that means it is sure yet it is going to work. In that case, they will implement that one in the standard. So that's what happening. So whenever you might have heard about yeah, we are doing in NOMA. In the model, in the waveform design, we can, that the physical area, NOMA, MASIMO, those are the research topics experimentally verified and added to the standards. So NOMA and all not a theoretical study, experimental and practical running setup is not yet shown. So whenever it is practically shown, and it is working well, then it will be implemented in the future. As of now, not. So we can also see some keywords like mm, non-terrestrial network, that is satellite communication, IoT over in IoT, and early stage in the artificial intelligence system, AML, and immersive communication. Here, release 14 itself, they had a mission critical data over LTE. So the future railway communication system, 5G vehicle to X communication. That is release 15 also it is there. So and release 16 also we have V2X. So extension and addition of new things will be incorporated in the releases. So this is one of the reason cell phone manufacturers release new phone models every 1 or 2 years, right? So Samsung, Motorola, any company, they make phones every few years to incorporate the 3G standard algorithm setups in the phone. That's one of the reason they release anything new phones. So this is the summary of the release 18 standard. So you can see the things, stuffs. So the objective is to, this is from 3GP website. So self-driving cars, smart cities, industry automation, smart homes, um, all the things part of that. So whenever we're talking about self-driving cars, industry automation, so all these concepts can be parallelly applied to smart agriculture also. So basically, in smart agriculture means we are involving sensors, actuators, and machineries we are involving, right? So whatever concepts we are trying in industrial automation, all those concepts can be applied in agriculture sector also. So you can see some key. I will try to show some keywords about what are the services. Basically, this is for release 18. Okay, release 18 means it is happening currently. So this is release timeline. So release started in 21 quarter 4, then release 18 stage 2, and release 24 almost frozen. Currently also it is running. So in the physical area, we can see MIMO evolution for doubling upling, artificial intelligence, machine learning for NRA interface. So these are the things being studied, and once it is successfully verified, it will be incorporated in the standard. So we can also see B2X, UAS application, unmanned aerial systems applications, that mean drones. Whenever the coming up drones means that is particularly part of the agricultural domain. So there is no specifically agriculture space, but in general, industry automation and COT integration is a part of the 5G. Sorry, 5G agricultural. So as I said, the standard development happening from 2027 to 30. It will be done within 3 years because that is the implementation period where all the 3GP parties will be involved and doing that. So from 2030 onwards, we'll be having the deployment, system deployment, that will be 6G. So summary. So basically, release 18 means 6G officially started. I mean, the study things are happening. Um, Practical implementation and testing will be done in 2027 onwards. Within 2 years, we will start talking about 6G only. We will be forget about 5G. That is the thing. So as I said, through TSTSA, India is contributing towards standardization. So why then how to utilize the 5G for smart farming? So currently, how we are doing the farming means the farmers are doing the farming based on their experience over the years. So 30, 20, 30, 40 years of experience. The experience, they know what kind of fertilizer they have to use, when to do the farming, when to crop. All they know the seasonal changes. They know it through experience. So uh, at the same time, it also has some drawback. That means these days we have a lot of environmental changes. Climate changes are not predictable. So the seasons are getting changed. So now we have to rely on the data driven instead of the experience based. So if you are having the sensors and if you apply the machine learning and AI techniques in the agriculture domain, you'll be make the better um, farming system. So when you think of agriculture domain, we know that around 70% of the population involved in the agricultural domain. So we should have a lot of sensors, massive number of sensors. As I said, similar to the industrial automation, here also we should have a lot of sensors, soil moisture, climate sensor, livestock sensors, um, and drones. Drones will be equipped with the cameras that will be feeding the um, video, images and videos. Um, they have a lot of requirements for automation, irrigation control and all. We need a low latency, and the coverage should be wide. We should it should cover the entire rural region. So the one difference is that in metropolitan cities we have um, a lot of population, so that we are having a lot of so many base stations. But in rural side, we will be having cell towers for every few kilometers, like 5, 6, 5 kilometers, sometime every 3 kilometers, and also. So since farming fields are very vast, we should have um, base stations that cover large region. So we will not be able to use 4G and other techniques like Wi-Fi and all, because since it involves large number of sensors and video feed and all through drones and such things, we need a very high throughput also. Um, a large number of devices. The 5G is only solution in that case. So whenever large number of devices are involved, we cannot send all the data to the cloud. Cloud is already uh, overloaded by the smartphone users data. And if you are feeding the agricultural things to the cloud, it will be overloaded. Then other users will be suffering. So for that reason, we have to process the data locally. That means close to the base station itself, we have to process the data. That's called edge computing. So multi-access edge computing means wherever the data is captured, the process that we can process it close to the base station instead of sending to the cloud. That's multi-access edge computing. That is one of the things that has to be included in this smart farming system. So basically, when you talk about 5G, you might have heard about there is enhanced mobile broadband, machine to machine communication, and ultra reliable low latency things. So they were different transportation, industrial automation. So all those different vertical domains has to be incorporated for the 5G smart farming setups. So these are the different features like non-terrestrial network, satellite, uh, integration satellite, NRIO, IoT setups, RedCap, reduced capability devices, already has been implemented in 5G time to time from release 15 onwards. So we can utilize all these capabilities to make a smart farming. So whenever you talk about autonomous machineries, tractors, autonomous ground vehicles, robots. So whenever you're talking about farming means not only the crop monitoring control, there are livestock monitoring also. Cows, milking. So we can use machineries for milking cows, livestock monitoring, all those things part of that. So what are the industrial IoT recommend that you can incorporate by the relaxed constraint for smart farming also. So in actual industrial automation, we need a very strict latest requirements, but in smart farming, we need to have that much of latest requirement. But throughput requirement point of view, it will be huge. For example, enhanced mile broadband means high throughput communication that is required for drone-based videos monitoring, right? And so if some farmer is having several acres of land, 10 acres, 20 acres, some are having even 100 acres of land, coconut plant, all those things are there, several acres, several several tens of acres are there. So in those things, physically going and monitoring the disease, all those things are difficult. So you can use the sensors and drones. They can fly around the region. They can collect the information within the 20, 30 minutes, and that can be processed in the cloud or local MEC server, so that you'll get a uh, fast monitoring. So, and for massive number of machine to machine communication sensors, you can use soil moisture, pH, and electrical connectivity sensors, and weather stations, livestock stat tags, all are part of the machine type communication. So, either we can use the 5G modem to these devices, or we can integrate other uh, networks like Zigbee, LoRaWAN, all those things also can be integrated part of the uh, farming setup. So we can also have autonomous ground vehicles. Already, John Deere and Mahindra already they are processing these driverless tractors. So this is part of this smart farming. They have different data requirements, data rate requirements in terms of several MBBS of data rate for drones and latency for controlling the vehicles, even the drones, and positioning also matter of buttons. So whenever you are putting the sensors, actually whenever you have smartphones, right, that they are having higher capabilities, right? It can have support 100 megahertz bandwidth. We can have a large, more power, battery backup, all those things. But when you put on the sensors and all, we cannot every time we charge and all, right? So the sensors and all has to be powered for several months or even several years. If you plant some sensors, that should have the power for several months, so that you need to change the battery, right? And it cannot have so much of processing power. It minimal computation power, all this required for the sensors. That is called reduced capability UEs. That is part of drone farms. And where the coverage is not possible, right? Through cell towers and all, the hilly domain, hilly or in the seaside regions, wherever the cell phone towers are not possible, we have to rely on the satellite communication. So in the device level, there are sensors, actuators, drones, robot, they are part of that. And in the access level, the base station or the GNB is the main anchor point for the sensors. You can also involve Wi-Fi. Wherever required, we can use Wi-Fi, LoRaWAN, and Zigbee modules. So we can use the public infrastructure. That means already Geo, Airtel, and all they are having the cell towers. So you can use those cell towers for smart farming applications. Or if large farms are there, several acres of land, they can deploy 5G, private 5G network. That means they can deploy their own 5G setup to cover their region. So in some places it can be hybrid private and public also. Uh, One example I can give. I think 3 4 years back, um, Robert Bosch has deployed 5G private network in their Bangalore factory with the help of ATAL. See, ATAL deploys in the first private 5G network in the Bosch, right? So um, that means see that they have invested around 800 crore project that is part of 5G. So the advantage is that the data will not go outside the network. That is, confined within your region. And all the if you see think of any factory that will be having a lot of robots, sensors, driverless vehicles. That those can be connected via 5G because 5G is having 5G based having can have larger coverage. A few kilometers of coverage is possible, right? Instead of using Wi-Fi and all, they are for smaller coverage up to some 10 meter, 20 meter like that. So like Robert Bosch already implemented that one in their factory. The same concept can be applied for in our 5G smartphone. And similarly, Adani bought uh, 5G spectrum to support their airports and uh, uh, ports. So most of the airports are handled by Adani. So in the airports, there are a lot of vehicles were handling the luggages, a lot of passengers, and a lot of vehicles are moving around. So in order to automate that setup, they also bought this 5G spectrum. So not for public cell phone usage, that is for their uh, to use it for their territory, like airport and port movement, all those things. So if you think of any solar system, there is a base station, the core network. That core network is connected to the cloud, and that is multi-access edge platform that is close to the base station or cloud. So and there are satellite links. These are the kind of overall structure. The drones, valves, pumps, actuators, they are connected to the base station, and the soil sensor, climate sensor, autonomous tractor, all are connected to the base station. The base station connected to the 5G core, right? Then 5G core interact with the MEC server, MEC platform, multi-access edge compute platform to process this large number of data. So here was this is individual single links, but there will be the numbers are large in uh, size. So in 5G, there is a concept called network slicing. That means so you can think of a highway where a lot of vehicles are moving around, going on, like buses, trucks, cars, and two-wheelers. So if they are going, together without any proper land management system, they will collide and the system will be collapsed, right? To avoid that, what they're doing, they are putting up lands. So the two-wheelers can go this path, four-wheelers in this land, all those things. So they coexist without any much stop issue. The same concept in 5G also. So we know that the drones will transmit the high bandwidth. So video transmission takes high bandwidth, and the sensors will not have that requirement. They can send data for every few minutes or every few hours. a small amount of data, right? Temperature, the pH level, all those small volume data. So if you are combining, and if you there is a electric vehicle are moving around, that also having latency requirement, ultra reliable low latency. So in these things, we can have a concept called slice. So in the core network, each service will have a different module, so that they without affecting each other, they can run successfully. That means each service, drone means that is a separate service, sensor separate service, and a vehicle separate service. And they will be having different requirements in terms of throughput, latency, all those things. So um, in 3GP already has this slice concept to support this kind of things. So um, whenever we want to do research on this area, we have to focus on uh, load balancing in the core network side, about how to admit the slices. Even because in the core, the edge computing module also having constraints, right? The capacity, the computation capability, and all. So how to, you know, particularly the industrial automation side, the requirements are different. In the small farming areas, point of view, the requirements are different. So you have to customize the uh, software packages at the core network side, so that without having ambiguity between the services, we can have flexible operation. So if you think of precision irrigation means, um, assume of several acres of land that is equipped with several soil moisture sensors, and also sensors for measuring the salt level. So instead of using fertilizer and water irrigation, same for all the areas, we can, based on the soil quality, we can very accurately pump the water or fertilizer, so that the resources are efficiently utilized. So already we know that the fertilizers and ureas and all, no, it is given to the farmers by the central government of India in a subsidy basis. The actual urea things are coming from outside, from Russia or other countries. India is importing that and distributing to the customers with this subsidy, the reduced price. So 50 kg of urea is around 250 250 rupees. That is actual price is very high. So it is kind of every year government of India also spending lots of crores of rupees for putting as subsidies. So if you can efficiently use the fertilizers in this precision agriculture wherever we need, so instead of uniformly distributing the fertilizer things, if you can based on the sensors, we will use soil moisture sensors, salinity sensors, and ammonia sensors. Accordingly, we can very accurately can distribute the irrigation systems. So latency is not a problem here. It will mean seconds only, not in milliseconds like industrial automation, robotic control. So autonomous tractors and harvesters, all that Western countries already automated the harvesting thing, all the things. So now in India also people are making driverless tractors. Um, so machineries can be automated through 5G. Here, uh, since it's a real-time operation, so movement of the vehicles are very important. So latency is very critical here. Um, so you can see John Deere already has So they have already they have autonomous drivers, tractors, but not 5G enabled. Um, in the future, they can be 5G enabled. If it is going to cover large area, particularly. So there are some videos available. Um, so you can just search for it, and you'll do automatically the tractors are being used for the farming side. These are under testing side. When this proper connection is made with the standard, so it will become fully automated. So drones can be used for disease detection. So so if someone is having 100 acres of land, is physically going and inspecting the setup is very difficult. So for that, the drones can be used to capture the video and image that can be processed in the edge computing platform, so that a lot of time is saved for the farmer. So uh, suppose if you want to do research work on the 5G enabled smart farming, so obviously we have to use sensors, actuators, drones and cameras. All those things are being used. That is already available in the embedded domain. So now, as a communication engineer point of view, we have to focus on these slicing and QoS support, all those things in the core network side. Whatever I said, the edge computing, the core network side, there are multiple components, network slicing, the QoS provision, um, traffic management, slice admission control. Those things should be topic to research. So if the number of based on the number of sensors, how the core network has to be designed to successfully after operate the setup. And if in the physical layer point of view, so when you think of smartphone communication, so all the users are moving in the uh, near the buildings, trees, and all. So already proper channel modeling has been taken out, and the system is designed for the scenario. So considering the kind of material being used in the houses, buildings, and how much loss it can create, all those things get taken from experimentally they had taken and done. But it is not the same setup cannot be used for agricultural domain, because mostly it will be on the open space, right? So in the open space kind of the setup, you'll be having line of sight sometime, and some maybe some trees blocking the signal quality. So these kind of uh, measurements has to be taken, and accordingly the system has to be designed. The various frequency ranges. So we know that depending on the frequency, the signal quality is going to differ. Um, so um, the sensors is going to be placed, under the ground in some cases. So how to make the channel modeling using integrated sensing and communication, ISAC, also good research direction. So the traffic prediction also one of the, so automatically learning from the past years climate data, we can do the smart irrigation, all those things. So one already existing example is that in UK they are using it for 5G setup for milking cow. So you can just Google it, you will get news that have came in a couple of years back. So this is more suitable when large number of cows are involved. In India, we don't have a very big farms with several thousands of cows. But already in the homes and small farmers having up to 10 cows, 20 cows, they are having it, right? So here you have to find out the scenario where it can be low cost livestock monitoring, milking setups can be produced. So the cows attached with some sensor that will be monitoring their pain and movement, other things. Then we'll send it to the 5G anchor point. So the anchor point will process the data and when to stop the milking of the cow. So we cannot keep milking the cow because it will get pain, and we should not leave the milk on the cow also. That is not good for health. So we have to how to optimally extract the milk from the cow. That already they have successfully deployed the cow farms in UK. So Denmark and UK are their top countries in dairy products, right? So they have a requirement. They have already done it. So in Indian scenario, you have to find out a ways to do that. This is one example how it can be utilized. So milking cow using 5G setup, but even whenever the setup is the farm is having large number of cows, the same setup can be used for health monitoring, like goats health monitoring and cows health monitoring. All the things possible. And also we know that currently in India we are having Jersey type of cows. They are suddenly they may go ill and they die. So if the cow dies means it's a loss of easily 40,000 to 50,000 rupees loss to the farmer. So for that, the government of India also spending a lot of money to put injections every year during rainy season and all. They put injection to prevent uh, um, the diseases. So whenever the sensor is attached to the cow, and it regular basis it senses the movement and temperature, and we can easily predict their health conditions. So and this is one example how already Geo has um, introduced the product called GeoKrishi. GeoKrishi is the 5G enabled farming product that can be useful for 5G application. See these. So this is basically our 5G enabled device that has a weather sensor, soil moisture sensor, and it has this is a weather station. Um, so it can be connected to the drones, spraying. It is for spraying. Like we can see that cows are attached to the collars. So in 24/7, you can monitor the health of the cow. So GeoCrease is the one of the first product we can say that is enabled by 5G, introduced by Reliance Industry in Geo. So GeoCrease, you can get the details of it. It helps to I mean the app you can so whenever it is in the farm, the farmer can connect via smartphone and monitor the farm anytime. So it can also uh, help to de- uh, detect the disease using AML techniques. And drone studies, drone spraying, all are enabled by 5G. So it can basically measure the nitrogen, phosphorus, and potassium NPK levels from the then soil moisture, pH level, and you can also find out the salt content. And in greenhouse setups, you can find out the CO2 emissions, all those things, right? So using cloud platforms, whenever it is sent to the cloud, it can give us the yield prediction and crop analytics, whether integrated irrigation alerts, all those things. So overall, massive number of the sensors will be connected to using MMTC, the machine to machine communication devices, machine machine type communication devices, utilizing involving a large number of sensors. And URLLC for real-time robotic milking and autonomous tractors. It's latency is very important factor. Drones sending video stream and image, right? So they need a very high throughput EMBB. Then technology already part of that. So these are the different features of 5G can be used for smart farming. So a multi-exchange computing for uh, disease detection. So whenever some camera device capture the uh, image, it will send to the cloud. In the cloud, the disease detection algorithm will be running. That will be giving us the feedback. So these are the concepts of 5G can be used for smart irrigation. Sorry, smart farming. So these are the few already we know that features of 4G and 5G. Um, not going to the detail much. So as I said, in 4G we have UE and for EMB all node base station, the MME, and there are some control gateways for controlling the connecting to the gateway. In 5G, it is replaced by the MME, the AMO, SMO, EPF, all those things are there. So these are the software packages running in the cloud that can be controlling the base station and the data. So in the 5G core, generally it is called service-based architecture. So we can add any service whenever required. Suppose we are putting up one drone in the farm, we can add one service in the core network side. Any vehicle, autonomous vehicle, that can be also connected. For that, each new service, new application or service, we can add one module in the core network as per wish. That is the main advantage of service-based architecture. We can create multiple components, replica of components for, so for example, if there is a UPF or SMF, we can create multiple UPF and SMFs for each slice. For drone, one UPF. For vehicle, ground vehicle, autonomous ground vehicle, another UPF. And for sensors, another UPF. Either you can create in multiple numbers. This would be useful whenever you are creating private 5G setups. And yeah, network slicing means creating a replica of that so that we can have independent operation. So edge computing is again, we have some processing unit close to the base station. For example, instead of giving the EPF and the core network, we can keep it close to the base station so that it can be processed at a much faster rate. Okay, so whenever we are talking about um, um, applications, we have to, it's no more only theoretical work, right? It's a very practical physical device-based setup. So we have to rely on the experimental 5G tested test beds. So already Government of India focusing on funding institutes for giving use case lab. Already Government of India has given 100 use case lab across India to to make applications like smart farming. Um, Already there are a lot of open source platforms available. We can also utilize them, like SRS RAN, Open Interface, Open 5G, Core Network, all those things. Um, so there is something called Open RAN also that will be moving towards 6G. Um, I will directly go to the test beds. So already IIT Chennai, IIT Hyderabad, IIT Bangalore, so with collaboratively they have developed one 5G test bed um, in 2022 or something. And after that, Government of India has given 100 use case lab for top institutes in India. Um, so you can create real world applications, something like smart agriculture and all those things, right? So in our lab also we are having uh, smart farming integrated setup. I will show some pictures, some possible some videos. So this is kind of a use case lab set the test bed in some institute. They have base station core network all are within their rack server. We then additionally we'll be having the drones, sensors, IoT setups that can be integrated. So first of all, why to build that test bed? So whenever you are doing research, theoretical research means we can focus on physical layer or such things that can be simulated and verified. But whenever you are doing the application level, the end-to-end system has to be deployed. That is, we cannot do it through simulations. We have to rely on the real hardware. For the real-time test bed is required for that reason. Um, so we even we have the uh, uh, test bed called the Finance Studio. So the main objective is to, perform UG and PG these projects and develop algorithms for 4G, 5G solar systems. So it's like a fully open source base station protocol stacks and the core protocol stack. So we can customize those things and we can test our algorithms and ideas. So we can connect your smartphones, any IoT setups, and we can do all kind of um, testing and verifications. So
Dr. Prabhu, you can bit you can try to wind up
yeah,
sometimes, so you can give the break
okay,
for the people, and we can continue after some time.
okay then. 5 minutes. Yeah. Okay. So here, how we are setting up the test bed is that this is a typical cellular system, base station, core network, and the internet, right? There are sense devices. So um, here we are using a central purpose CPU and some SDRs and user equipment and IoT modules to create the test bed. Using that, basically this IoT setup that data can be gathered and processed. I'd like to show some.
Thank you so much, sir.
Yeah.
And there is one question from the participant, not the one, more than one, sir. Can we use
Okay.
this sensor for underwater animals as we used like in
Where is it?
geocaching?
1 second. Where
Hello?
it is given? Yeah, where
Am
is
I
it? Chat
audible, sir?
message? Yes, yes.
Yes, sir, in the chat box, sir.
Oh, so let me.
From Dr. Deepa Nayak.
Okay, it's not loading here. Can you tell me the question?
Yes, sir. This question is from Dr. Deepa Nayak. Can we use this
Okay.
sensor? Can we use this for underwater animals like geokrishi?
Actually, I have not gone through that in detail. We have to see the technical details of the geocaching.
Actually,
Maybe in
underwater
their
possible, Dr. Prabhu. Actually, thing is that underwater, it will work for the underwater environment also. Only thing is that the range that is going to cover by this antenna is going to be very less because of the salinity that is going to be available in the water. So it will
okay.
not be able to reach for a longer distance. So accordingly, we have to maintain the environment.
Okay, actually, we can also add some secondary network like Zigbee, LoRaWAN, or Wi-Fi, so that it extends the range.
Yeah. Same thing I wanted to say actually.
Right. Okay. But I haven't personally used the
Thank you, sir.
geocracy product. So if someone has this geocracy product, then they can answer that. Yeah.
One more question from Dr. Savita R. Bhosle.
Hmm.
How are issues such as dust, heat, uneven land, and animal interference handled for towers, sensors, and robots in 5G, 6G enabled smart farming?
Okay, few lines I couldn't listen. First few lines. Repeat again.
How are issues such as dust, heat, uneven land surface, animal interference handled for towers, sensors, and robots in 5G, 6G smart farming?
Dust interference.
Interference, sir. Animal interference.
I'm not getting the
Maybe the
question
question
clear.
is something like that.
The
What is
issues that
the
the issues they are asking that how are the issues like dust environment. Then if it is a dusty environment, if the heat is going to be there, or if the land surface is not even, and if some animal is going to enter inside the zone of the tower, how the sensors and the robot are going to work in the 5G or 6G enabled smart farming environment.
Actually, when you see the colors, no, it is well designed such that it is not affected by the dust and all. So, and one more thing is the 5G modem is not directly going to be connected to the device. The secondary network will be communicating with the cow.
Actually, I think Dr. Prabhu, can I answer?
Yeah, tell me.
So actually thing is that this dusty environment, this heat environment, or if suppose the land surface is not going to be even, it is not going to be affected by the tower because tower is going to radiate your microwave energy. And
Right.
the sensors and the robots which is going to be available in your the devices or the nodes we can say. So those are going to sense it and they are going to transmit the data. So this data when it is going to be, again it is going to be in the form of micro energy. So which is not going to be getting affected with your dust, or which is going to be, it's not going to be affected with your heat. If you want to have a network which is going to be in the optical domain, then all the issues that you are saying will be affecting the your the data communication. But as far as your the wireless network is concerned, this is not going to affect it because we are already getting exposed with all this environment.
Okay.
Thank you, sir. There is no more questions from the audience, sir.